Today I am going to discuss about the maximum power transfer theorem. From the word maximum, that means you have some maximum value. Power means what in terms of V into I. Transfer, that means there should be some source and should be the destination. So maximum power transfer theorem actually explains that when the source resistance is equals to the load resistance, then the maximum power transfer taken place from source to load. Okay, so where it will be applicable, where the maximum power transfer actually required. In case of the communication engineering circuitry, where the maximum power transfer required means that from the source to the destination, from the transmitter to the receiver, the maximum power should be delivered. So if we consider for explaining the maximum power transfer theorem like this circuit, suppose this one is a voltage source and like a series resistance, suppose this one is a series resistance. In case of here, the internal resistance of this source it is small r, and and this one is the Rs, and this one is the load resistance. So this one is the source end where we apply the potential V. So it will be the source and this one is equals to the load. Okay. So the current flowing through this circuit, it is I. If we consider this circuit like this, so this one is a V and this one is the R and this one is the L. Okay, this one is the RL and this one is R, where capital R this equals to small r plus Rs. This one is a V. So the current flowing through the network is I. If it is flowing through the load, then it is a IL. So IL is equals to V by these two resistance R plus RL. Okay. So when you considering the power, then we know that P equals to V into I. So in case of V, we put that IR into I, that means it is a I square R. For the power at load, that means the PL max or PL. Suppose first of all you have to understand the what the value is the PL. PL equals to what? V equal P equals to I square R. You have the value for the IL also. So it is IL square. So IL value is a V by R plus RL. V by R plus RL. Then it is square into RL. So that the V square by R plus RL whole square into RL. So it is a value for the PL. So when you go for the maximum, then PL max. Then what will happen? When you transfer the maximum power from source to load, then you have some specification of some predefined condition, like that dPL, derivative of this one with respect to the RL is equals to 0. That means from this equation you differentiate with respect to RL. Then what will happen? This one dPL by dRL. Okay. Then V square is a constant term. Then it is a U by V method. So it is a R plus RL square. Then it is a whole square. So it is a to the power 4. Okay. So it is a V square. The constant R plus RL to the power square. That means the V square. That means to the power 4. So next one R plus RL square. The derivative of RL 1 minus the derivative of this 2 into R plus RL, and then this one RL. Okay. So this one these values goes to 0. So it is a 0. Next one V square by V square into R plus RL square minus 2RL into R plus RL divided by R plus RL to the power 4. So this one are cancelled out. Okay. So V square also cancel out. V square, why it is cancelled out? It goes to this. Then it is cancelled out. Then R plus RL square equals minus 2RL into R plus RL equals to 0. So R plus RL square equals to 2RL R plus RL. Okay. So this one are cancelled out. So R plus RL is equals to 2RL. So R equals to RL. So this one R equals to RL. This one is a specified condition when the maximum power transfer theorem taken place. It is only applicable when the source resistance is equals to the load resistance. So now we calculate the power PL max. For this one, PL max, maximum power transfer theorem, is what? V square by R plus RL whole square into RL. So what will happen? V square by R equals to RL. So it is a 2RL whole square into RL. So it will be like that. PL max is equals to V square by 4RL square into RL. That means V square by 4RL. This is the condition for the maximum power transfer theorem. Okay. Now we have to derive the previously we have derived R equals to RL. Now we derive PL max equals to V square by 4RL. Okay. In the next video we will discussing about the node analysis and mesh analysis.